Welcome to Joey's Tech, my friends. In this video, you will learn the counting sort algorithm. I'm going to tell you first how the counting sort algorithm works. Then we will implement the counting sort algorithm using a Java program. And finally, you will learn the time complexity of the counting sort algorithm. But before we get into how the counting sort algorithm works, let's know a little bit about it. So counting sort is a sorting algorithm that sorts the elements of an array by counting the occurrences of each distinct element in the array. The count of the elements is stored in another temporary array. Then certain arithmetic operations are performed on the temporary array to find out the position of each object in the output sequence. Here are a few more characteristics of the counting sort algorithm that you must know. Counting sort is not a comparison based algorithm. It hashes the values in a temporary array and then uses those values for sorting. Just because it uses a temporary array, it is a non-in-place algorithm. And counting sort algorithm makes assumptions about the elements of the array, such as it assumes that the values are going to be between 0 and 9, or the elements of the array are going to be between 0 and 99. And it also assumes, and it is obvious that it assumes, that the integers will be positive. Now, one important question: when is counting sort used? So you only use counting sort when the array contains smaller integers multiple times and when linear complexity is the need. Alright, that was enough theory on counting sort. Let's now start understanding how the counting sort algorithm works. This is our problem array that we are going to sort using the counting sort algorithm. We are first going to create an auxiliary array, or in other words an array that is going to store the count of each unique element. But what's going to be the length of this auxiliary array? That's a question, right? To find the length of the auxiliary array, we are going to find the maximum element from our problem array. So you can see the maximum element from this array is 8. Therefore, the auxiliary array must have the indexes from 0 to 8, which states that the length of the array is going to be 9. Let me create that array now. Alright, the temporary array has been created now. Now let me fill this entire array with zeros, as it is going to hold the counts of the distinct elements of this problem array. Now we will store the count of the respective elements in this array. If any element repeats itself, then we simply increase its count. How do we do it? We'll start from the first element of the input array. The value here is 4. So we'll increment the value by 1 at index 4 in this array. So the value here will become 1. We move to the second element now. Here the value is 3. So we go to index 3 in this auxiliary array and increment its value by 1. Over here we have 0. 0 plus 1 gives us 1. Okay. We move to the next element now. Here the value is 3 again. So we go to index 3 of the auxiliary array. Here the value is 1 already. We increment it by 1. So this value is going to become 2. Alright. We move to the fourth element. Here the value is 8. So we move to index 8 of this auxiliary array. Here the value is 0. We increment it by 1. So here the value becomes 1. We move to this element now. Here the value is 2. So we go to index 2 of the auxiliary array. Here the value is 0. We increment it by 1. So the value becomes 1. We move to the next element now. Here the value is 1. So we move to index 1. Here the value is 0. We increment it by 1 and it becomes 1. We move to the last element of the problem array. Here we have 2 as the value. So we go to index 2. Here the value is 1. We increment it by 1 and we get 2. Alright. Okay, so we have the temporary count array fully filled with the counts of distinct elements of the input array. Now what the next step will be? Now we need to store the cumulative sum of the elements of the count array. We will modify the count array such that each element at each index stores the sum of previous counts. So let's do it. The value here will be the result of the addition of 0 and 1, which happens to be 1. So no change. The value at this index will be the result of the addition of 1 and 2, which is 3. So I'm going to put 3 over here. The value at index 3 will be the result of the addition of 3 and 2, So the value will become 5 over here. Over here at index 4, the value will be the addition of 5 and 1. So the value here will become 6. The value at index 5 will be the sum of 6 and 0, which happens to be 6. So let me put 6 over here. Over here the value will be the sum of 6 and 0. So I'm going to put 6 over here. At index 7, the value will be the result of the summation of 6 and 0. So I'm going to put 6 over here as well. And finally at index 8, the value will be the sum of 6 and 1, which will be 7. Okay. Alright. Each index of the count array stores the cumulative sum of the previous counts. The modified count array indicates the position of each element in the output sequence. Let's see how. So for that, we are going to create an output array that will be of same size as the input array. So here is how the counting sort algorithm is going to work now. The first element in the input array is 4. So we go to the count array and check the index 4. What's the value here? It's 6. Now we subtract 1 from 6, we get 5. And that is where we put 4 in the output array at index 5. Let me put 4 over here. Also, the value at this index will be updated with 5. Why? You will come to know in a while. We move to the second element of the input array. The second element is 3. So we check index 3 in the count array. Here the value is 5. We subtract 1 from it, we get 4. That is where we place 3 in the output array. So let me put 3 over here and we update the value at this index with 4. The third element of the input array is 3 again. We check the value at index 3 in the count array. Here we find 4. We subtract 1 from it, we get 3. So we place this 3 at index 3 now in the output array and update the value at this index with 3. So you understood why we were updating the count array with the subtracted value? Because it helps in finding the correct index for the element that repeats itself. We move to the fourth element of the input array, which is 8. We move to index 8 of the count array. Here we find the value is 7. We subtract 1 from it, we get 6. This is the index of the output array at which we are going to place 8. So let me place 8 over here and I'm going to update the value at index 8 with 6. We move to the next element, which is 2. So we go to the index 2 of the count array. Here the value is 3. We subtract 1 from it, we get 2. That is where in the output array we are going to place 2. Okay, and we are going to update the value at index 2 of the count array with 2. We move to the next element. Here we find 1. So we check the index 1 of the count array. Here the value is 1 again. We subtract 1 from it, we get 0. That is the index at which we are going to place 1. And we are going to update the value at index 1 in the count array with 0. Alright. Now we move to the final element of the input array. We find 2 over here. So we check index 2 of the count array. Here we find 2. We subtract 1 from it, we get 1. And that is the index of the output array at which we are going to place 2. Also we are going to update the value at index 2 of the count array with 1. Okay, and there you go. Our problem array is sorted now. We can now transfer the elements of the output array to the input array and present it as the sorted version of the problem array. Now let's quickly implement the counting sort algorithm in Java. Alright, so within the main function, I'm going to first declare and initialize my problem array. Let me call that as input. And I'm going to put in the elements of the input array. So it will be 4, 3, 3, 8, 2, 1, 2. Alright. Now I'm going to find the size of the input array. So I'm going to declare a new variable known as size. and it will be equals to input dot length. All right, let me create an object of the class which will be used to call the counting sort function. So I'm going to call this object CS. It will be new counting sort. All right, and it's going to call the counting sort function. So let's name the function as count sort. I'm going to pass as the first parameter the input array, and as the second parameter I'm going to pass its size. All right, function doesn't exist as of now, that's why you see it in red. So let's create the function. Okay, so it will be void count sort, and the first parameter will be an array, let's call it inp, and the second parameter will be an integer variable containing the size. So I'm going to call it size again. Okay, now within the body of the function we are going to first declare two arrays. One will be the output array, so let's call it output, and the size of the output array will be the same as the size of the input array. Okay, now to create the auxiliary array or the temporary count array, we need to find the maximum element from the input array. So to do that, we are going to declare a variable known as max, and we are going to initialize it to the first element of the input array. All right, let me provide comments over here. Find the largest element of the input array. All right, now we will write the code to find the maximum element from the input array. So it will be for loop. There will be a variable I which is going to start from 1, and it's going to run for the length of the input array. All right, and within the for loop there will be an if condition which will say if element at index I is greater than max, then that element will be assigned to the max variable. All right, this is the code to find the maximum element from the input array. Now we are going to declare the auxiliary array. So it will be int square brackets aux, I'm going to call it aux, new int square brackets, and within square brackets I'm going to write max plus 1. All right, if you remember, the maximum element from the input array came out as 8, and we created an array of size 9 because we needed indexes from 0 to 8, hence max plus 1. Now the next step will be to fill the auxiliary array with zeros. So we are going to write a for loop. It will be I again, which is going to start from 0. It's going to run for the length of the aux array, and within the for loop we are going to assign every element of the auxiliary array 0, like this. Now the next step will be to store the count of each element in the aux array, for which we are going to again write a loop, and it will be I variable again. It will start from 0. It's going to run for the length of the input array, and within the body of the for loop we are going to write aux. Within square brackets it will be inp, within square brackets I, and outside we are going to use the increment operator. Okay, this is going to store the count of each element of the input array in the aux array. Now after we have stored the count of each element of the input array in the aux array, the next step will be to modify the aux array to store the cumulative sum. So for that we are going to write another for loop, and it will be I again. It's going to start from 1 this time, and it's going to run for the length of the aux array. And what we are going to do within the for loop, we are going to simply write aux at index I equals to aux at index I plus aux at index I minus 1. All right, this is going to store the cumulative sum at each index of the auxiliary array. Now we come to the climax of the counting sort algorithm. where we find the index of each element of the input array in aux array and place the elements in output array. So we are going to write a for loop that is going to start from 0, the first element of the input array, and it's going to run for the entire length of the input array. So it will be I less than size I plus plus. All right, and within the for loop we are going to write output array, because that's where we will be putting in the element, and within square brackets. So what we did here, we picked the element from the input array and we checked the index represented by the element for the value from the aux array. So it will be aux, within square brackets it will be inp, within square brackets it will be I. All right, and then whatever the value here was, earlier we had 6, so we subtracted 1 from it, so we got 5. So over here we are going to subtract 1. All right, so when we got 5 at index 5, we put the picked element from the input array. So after equals to, it will be inp, within square brackets I. All right, and after that we updated 5 because it was calculated on the go. So we updated 5 at index 4 in the aux array. All right, so the next line of code within the for loop will be aux, within square brackets inp I, and after the last square bracket decrement operator. All right, so whatever the value here is, we are decrementing it by 1 always. Okay, now the next step will be to copy the elements of the output array into the input array. So it will be for loop again, int I equals to 0. It's going to run for the size of the output array, and the code will be simple. It will be inp at index I equals to output at index I. All right, and finally in the main function I'm going to write the code to print the input array after the count sort function is called. So it will be system.out.println arrays dot toString, within brackets I'll pass the input array, and let's print the original input array as well. So it will be printed before counting sort classes object gets created. All right, now let's run this Java program and check the output. This array over here must be sorted. When this program runs, there you go, you see the original unsorted problem array over here, and beneath it is the array sorted by the counting sort algorithm. The Java program implementing the counting sort algorithm is working. Let's now look into the time complexities of the counting sort algorithm. The best, average and the worst case time complexities of the counting sort algorithm are the same, which is big O n plus k, where n is the number of elements in the input array and k is the range of input. With this, we have come to the end of this video. I am sure you enjoyed learning the counting sort algorithm from Choice Tech. I have created videos on other sorting algorithms as well. Make sure you watch them all to learn them all. I'll see you in the next video of Choice Tech. Till then, goodbye and take very good care of yourself.